Welcome back. I hope you all enjoyed a bit of stretch and a bit of on the march jogging or whatever the case may be. Welcome back, and I'm going to show you and teach you the ARM Cortex M4 in detail. This is the basic block diagram, what's inside the core processor. It has nested vector interrupt controller, NVIC. It has wake up interrupt controller. When your device goes to sleep mode, through this you can alert the device to be back in operations. The main is the CPU with the DSP extensions. It has its optional floating point unit. And when you talk about debug options, so it has debug access ports through a serial wire viewer. It has its data watch points and breakpoints, ITM instrumentation trace, macro cell trace, where you can be checking through printf sort of statements, and you got the embedded track macro cell trace. And the bus matrix is composed of, it has its own memory protection unit to protect everything in the Cortex series. And this is in-depth bus connections inside the Cortex M4. As you can see, the whole code inside it sits in with NVIC, the floating point units, and that's the core, main core with the FPU. It has its memory protection, the data watch point and trace. It has the embedded trace macro cell, the trace point interface unit, and all the bus matrix that starts with I code, decode, and system HB. The debug point comes with a serial wire debug or a JTAG debug to debug your program. And wake up interrupt control, if your device, when it goes to sleep mode, through this interface, you can alert the device, get it to functional. Let's get deeper into understanding about what's inside in the core features. So the M4 Cortex M4 core series is a subset of thumb instruction set, which was defined in ARM v7 architecture. It has banked up stack pointer to stack up all your memory, and it is the hardware integer points here is divided into signed and unsigned divider, which you will learn when we start to learn about the programming. It has two different modes of handler program modes and the thread mode, which you will learn shortly what it is about. And it has thumb and debug states, different states. And the processor core supports for uninterrupted instructions on LDM, STM, push and pop, for low input latency. And automatic processor state saving and restoration for low latency for service routine for the interrupt ISR. If something gets interrupted, then it is got its own saving mode. And the has its own support V6 version. We're going to use this V6 version with big Indian and byte invariant or little Indian. What it is big Indian stores your magnificent more significant bit, and little Indian stores your least significant bit in your 32 byte word. So that's what it supports. So this is the main core features. Now let's move into floating point unit. The floating point unit comes with 32-bit instructions to form C-float precision data processing operation, combined with MAC capability. You can multiply and accumulate to increase the precision. And also the hardware inside supports basic conversion, addition, subtraction, multiplication, division. And also you can do square root if you want to go further deep. And it is IEEE rounding modes that matches IEEE standards. And it has its own 32 dedicated precision registers with 16 double word registers. So a word is a 16 digit, and to get to 32 bit you need to use two 16 double word registers. The next one is we're going to talk about the nested vector interrupt controller and the wake up interrupt controller. The both has the low latency interrupt processing. It has external interrupts, and it can handle up to 240 priority interrupts. So again, you will know more about priority as we go deeper into how it is all configurable and customized. So the bits of priority starts from 3 to 8 configurations, configurable from 3 to 8. It's got dynamic reprioritization of interrupts and the priority grouping due to the priorities of the interrupt, so it can form its own group. And the process state automatically saves if the interrupt occurs and if it wants to exit and re-enter, so that state is saved. And as I said earlier, if your processor goes to sleep through this interface, you can alert the processor to get back to its functional mode. Next is the memory protection unit. We're going to see what it is. So it prevents any corruption of your data in the processor, and it has 8 memory regions. So the sub-region disable SRB enables its regions to use most of it, most use of the spaces. That ability is to enable a background region that implements default memory map attributes, so it can map to any newly added memory location. So the memory protection unit is that to protect the extra memory locations. Next, we're going to see about the interfaces. The interface is linked with the main bus matrix. The bus matrix is a 3 advanced high performance bus, as we saw in the functional diagram earlier. So it interfaces with the I code, the instruction code, the D code, the design code, and the system bus interface. So that's the instruction interface and the design data interface and the system interface. It's all comes from the main bus matrix, and it divides to whether you're going to target the memory for storage or you're going to use a I/O from the peripheral. So that's where the 2 different buses comes in to picture, with linking with the advanced high performance bus to the advanced peripheral bus through a bridge. And these 4 are the APB debug system interface. You can use that to debug your program. So now let's move on to see about the debug features. The debug features has what you can see as the embedded trace macro cell. It has the serial wire or JTAG debug port. It has an instrumentation trace macro cell. It has the trace point interface unit TPIU, where you can trace in the program sequence. You can trace and see where the program is and where your debugging level are up to. So all these individual modules does its own functionality, so it is nice to have all of this in one processor. Now let's move on to learning about what's the programmer models out there. As you know from the first few slides back, there is 2 different modes. There is a thread mode, program mode, and a handler mode. The handler mode is if there is any the handler mode is if there is any interrupt that comes and knocks your door. For example, if when your processor is doing something, and if there is something it's interrupting, so it will stop at that time, and then it proceeds to what the interrupt priority is about, and it will loop again to go to the thread program mode. And the best programmer models comes with 16 register banks, so the R0 to R15. The R13 is used for stack pointers. The R14 is for link registers. The program counters, all your program based data comes in here, and it has special purpose registers with program status registers, PSR, the control and the prime mask, and the M4 series have even additional mask registers. It comes with 2 levels, privileged and unprivileged. So this is the baseline programmer model. In brief, the handler is interrupt handler routine sequence. when there is an interrupt service routine that happens, that's what handles the main, and it allocates a priority. And the thread comes as a normal program. So from the handler, whatever it gets, the message from the handler, the thread, um, by automatically with the privileged mode and the unprivileged mode, it acts to that and then send back its request back to the handler mode. So now let's get deep into the STM32F11RE block diagram. So I would like you to click on this link and get into the block diagram so I can give you an in-depth explanation about the block. So if you go to page 15 on this reference manual, sorry, it's loading, just one sec. I will maximize this and zoom this a bit so I can see. I think you can see that. So the block diagram that I've seen with all the basic blocks, so that's what you will see in the reference manual at page 15 in the reference manual. And this is the in-depth architecture inside that block diagram. So it has got all the GPIO ports and it's connected through the advanced high-speed bus. If anything, that's talking to your memory for storage, so the direct memory accesses and all the USBs with anything high speed oriented, it's all connected to this bus, the high performance bus. Whereas when you want to interface a keypad, a display, or in this case the timers, it all has to be connected via a APB, the advanced peripheral bus, and through this you can communicate to the processor. And the peripheral bus again divides that into two, with APB1 and APB2. And the APB2, which has all the timers and the UART machines and the SPIs and the other, as you can see, the temperature sensors and the ADCs are connected through the APB2. If you go along with this block diagram, this is about in-depth about what each and every bus are doing. So I won't bore you much with this. Just this is to give you just a reference. Okay, just one sec. And if you want to know more about STM32F411RE, that's the link. You can click that and you can find yourself all about this programming, this processor, the STM32. So I won't bore you with that. Okay, I'll give you just a little bit introduction about the memory architecture and the bus architecture by going into the reference manual. And this is to show you how the memory is mapped in your design in the ARM Cortex M4 series. Sorry, it's loading and it's loading. I'll bring it to you and show to you in a sec. This is on page 62 in the reference manual, page 62. Yeah, just this is the picture I put in the slide. So this is just to show you how the memory mapping is sitting in. All the circle that you see in this diagram, meaning it's optional, you can connect. For instance, the ARM Cortex M4 instruction bus can be also connected to flash memory through iCode. Likewise, the data bus can also be connected via data code to flash memory. So this is just to give you an idea about how the memory mapping is sitting inside that memory protection unit that we discussed a little bit earlier. And this is the bus matrix to show how that memory from the various buses, how it's going to integrate and where it's all sitting in terms of the memory locations, like SRAM1, where it is sitting, SRAM2, and if it is connected to the high performance buses, where it's connected and how the memory is connected. For example, the system bus is connected to the high-speed bus. So this will give you the memory allocations about when you send some information to save and where it goes and sits in your processor tree, and this is how it is. So as I was saying earlier, the memory map with the Cortex M series, so every memory location starts with the starting address and the end address. As you can see, the memory map is with the input-output line. The on-chip RAM, the program memory where your fundamental program to run the chip sits between 0 cross 00, it's in hex 0 cross 000 to 0 cross 1 series. In that location, the on-chip ROM is got all the information, and below that is the data memory address, the RAM. All the memory that's saved for data, it will start in 0 cross 2000 to 0 cross 3 FFFF. And then all the peripheral data will be located on this with the IO register as per the manufacturer's principles. They also prefer you to have all the information that's coming through peripherals starts with 0 cross 4 dot 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 to 0 cross 5 FFF. And you need to have a bigger external memory off chip, because sometimes if you want to extend your memory when this is running out, or if you want to use for more complex projects, and that's where the external memory address sits from 0 cross 666 to 0 cross 9A 9FFFF. And the external devices memory starts with 0 cross A to 0 cross D FFF. And the Cortex CPU terminals, they start with the nested vector interrupt controller and the sysdic. They sit in this peripheral with 0 cross E to 0 cross FFFF. So this is how the memory is mapped inside your project when you start to code and want to send the data across the program memory where it sits on-chip RAM, the data memory where it sits on RAM, the peripheral data where it sits between these two. So likewise, this is how the memory is mapped. Now let's move on to the comparison. So far we have learned about the block diagram, the processor families, and about its architecture based on von Neumann or Harvard. So now just to give you a small comparison in terms of its scalability and compatibility with the architecture, the Cortex M0 works on 90 micrometer design. It's used for lowest area for low power applications. And then the Cortex M0 for further up, it's used for highest energy efficiency when your project needs higher energy rating. That's where it's used. And then they developed to ARM Cortex M3 for more wireless based for energy performance boosters that you use. And the series that I'm going to teach you here is the ARM Cortex M4, because it has got the blended DSP with the floating point and precision to add to that, and also it has a better high performance. So that's why the Cortex M4 is really good. And Cortex M7 is more advanced for more processing. If you want to do more processing, that's where Cortex M7 is used. So this is in general about all the Cortex M4 series. And just to recap about today, we learned about the top overview about the ARM and why we went for ARM and its core versions, different versions, V4 to V6, V7, the architecture extensions about the trusted zone environment, the JSO, how and where it suits to your project needs, and the processor modes, the thread mode and the handler mode. Sorry, I have a bit of a problem. And what is about AMBA, the advanced microcontroller bus architecture, and about the various different families about F4. And then detailed explanation about the block diagram and how the memory is stacked in your program, and a comparison of the whole M0 to M7 Cortex series. as I said earlier, from the first day, you're going to learn more about how to prepare your mind to learn and be more successful. So I sent you a YouTube link which was shared with my by from my mentor, and this is from Frank Kearns. He explains about how a perfect day you could have. Like you can dream of having a beautiful day and how you're going to make things happen. Like how you can achieve your dreams by following certain things in a proper disciplined way. And I'm sure this will change your attitude towards others. Like everyone has their own goals and attitudes. So if you go through this video, then you will be more disciplined, more organized, the word to use, more organized to with your activities and tasks. And also the next one is the involvement, so the mindset will, that you want to create in moving along with this course. So just the general, write your 10 goals and the 10 ideas, and 30 minutes, please avail yourselves for 30 minutes every day to do any type of activities, walking or running. If you want to go to gym, do something in the gym, and at least please spend 15 minutes to meditate and pray, and also 10 minutes about visualizing about your goals, and about 10 minutes to plan for your day, and 2 hours of learning. So all this will fetch you 10 points. So whatever you are be able to do in the day, please do that, and then please share that achievement in the Facebook group, so everyone else will follow that and will get motivated and will help each other out to learn further. And that's not all. There is combo internships coming your way with embedded C programming with the current series Cortex M4, and just not far off, we have the bundle offer to come your way that will include all of this. So please stay tuned with me, and there is a lot there on offer for you. So I humbly and strongly advise you to join the internship program just for your own benefit, so you can get hold of all the materials that I'm going to use, the PowerPoints, the videos, and the backend support, and of course the source code for your reference. So this will be all useful when you want to prepare for that interview and land to that beautiful job that you are aiming to get. Because it's a lifetime validity, you can go back at any time and you can refer back, whereas the YouTube viewers, you can only see that only for 3 days. After that, everything will be removed, part of the YouTube deal. So I strongly recommend you to join our internship with A2DG, and we will look forward to providing you more services through our education system. And I thank you again so much for your patience on your day 3 to learn about in depth about ARM Cortex M4 series. And please go and get that lovely break that you deserve from the screen. And I'm Arulan Bukarasu. I'm signing off on behalf of A2DG. And until I see you on day 4, it's hooroo from me. See you on day 4. Thank you. See you later.